of the biggest things that we're doing from the embedded world is OPC UA provides a service-oriented architecture where a lot of the people want to take the data directly from the device and quickly push it up into the cloud. UA provides a simple infrastructure and a secure infrastructure that provides that across the firewall into the cloud through a standard protocol that even recognizes what these complex data types are, allowing other generic applications to be able to consume the data directly from the cloud. We've been in a cloud world for a long time, and now this is the mechanism for industrial automation and many of our other domains to actually have a centralized repository for all their data. We have been working with many organizations deliberately on the security front. The German government has started an initiative specifically where they looked at the OPC UA architecture, our specification, and more importantly actually what we call our stacks and implementations, and they have validated that we are secure. We also use a number of other third-party organizations, including such organizations as ISA Secure and WorldTech, to again validate that we have a secure infrastructure. Now I should tell you one thing. We actually didn't develop it. We actually use what's known as the Web Services Interoperability Group mechanism for security, which is based on a lot of the secure protocols that are actually used in the financial and retail market. When OPC Classic was developed, it was based on the Microsoft technology where we're looking at more of interoperability on standards Windows type platform. With OPC UA and what we've done, it's provided a mechanism between what the foundation does and a lot of our different vendors to really help other consortiums actually build products that support their complex information models. One of the biggest strategies we have because of our collaboration is the chemical and the oil and the pharmaceutical and the building automation are all many of our organizations that build companion specs that allow a mechanism for describing and moving data and information between connected devices. And this is one of the high premises of having an OPC UA, what I call type structure, an information model, as part of our base level functionality. And there's many tools and many products that embrace this technology for a reason, because everyone wants to be able to have industrial automation talk to building automation and vice versa. As part of our collaboration and work we've been doing, we're always looking for what are the next things that we really need to be doing. And there's a lot of things going on with the Internet of Things and Industry 4.0, and we're looking at some advanced technology that gives us some even greater mechanisms to support this device-to-device connection. Particularly when you have so many different devices you want to connect, it's important to be able to embrace a mechanism that allows even greater scalability. So one of the technologies we're looking at, and your audience may be aware of, is a multicast. And a multicast architecture allows one connected device to send to a whole bunch of other connected devices, and then each one of those connected devices essentially picks out what's important to them. And that's probably one of the key strategies that we're putting forward into our OPC UA protocol, again, from a device-to-device standpoint. Sometimes we talk about publish, subscribe, and this is another mechanism for we publish data and the guys over here are subscribing that. So we have a new mentality that will allow us even further ability to have more connected devices, because you know what, we just are going to have more and more and more as our vision of interoperability goes on. Everybody wants data. OPC UA is a mechanism for describing and communicating that data independent of what the devices are.